Welcome to part two of the metrology.net training and how to build test packages. This one, we're going to cover the measurement uncertainties and how we do measurement uncertainties in metrology.net. And then we're going to show you how to run a procedure and get your data out of metrology.net. So, all right, the next part of this is going to be how we do measurement uncertainties in metrology.net. And really what we want to do is get this tied more into how your labs do their 17025, those of you guys that are 17025 accredited. So what we did is we came up with to give you some of the background, we came up with a way to do it with Excel and a way to do it embedded. Then when we did the version 2.0 update, there was only one company that was using our embedded calculations. So we kind of put a pin in upgrading that to the 2.0 and stuck with the spreadsheets because that seems to work very well. So moving on, I like to start off with some quick questions here. So I'll pull up the chat and let me know who you guys think is the person responsible for primarily doing your measurement uncertainties. The programmer, the quality manager, the lab manager, or the technician. And me, unfortunately, I handle all those roles, so it gets thrown on me quite a bit. Then moving right along, so we did this training around a 410, a Transmill 410, and the Transmill 410 being the new calibrator that was coming out. So we had a company out there, ERP Technologies. So they went out and created these measurement uncertainty budgets based on the model. So this right here probably looks very familiar to people. This is something you're typically going to hand the auditor when he's going to come in and look at your measurement uncertainties. The one thing that some people will put down here is they might put degrees of freedom, and then they'll calculate the distribution based on the degrees of freedom. There's a function in Excel that's not available in POI, which is the tool that we're using, or available in OpenOffice that does that calculation. So we'll have to use a different different formula when we put in there because that formula doesn't work that's available in Excel. But the rest of this pretty much works. I've even had some people put in some drop downs for the distributions and automatically fill those fields out. Those work. Just once it's uploaded, those drop downs don't work anymore. It just looks at the values that are in the fields when it converts it over to POI. See, there's some discussion on ways to calculate measurement uncertainties here in the chat. So one of the things I've found over the years is everybody's got a different idea about how to calculate measurement uncertainties. I even saw two people in a track presenting two different ways to do measurement uncertainties, and there was almost a fist fight at a trade show because they couldn't come to agreement on how to calculate measurement uncertainties. The goal to this is that it allows you guys to calculate measurement uncertainties however you want to, and you're able to override the measurement uncertainties that are produced by CalLab Solutions with your own uncertainties as you're doing the calibration. So, but this is the main part of the sheet, and I'll bring a sheet up in an example once I go through all of these pieces parts. So then one of the things that's in the sheets is going to be the type B lookup of the specifications. So we do that here with the values that we're looking at. So 220 millivolts, this voltage, this frequency, then the next voltage, the next frequency. And then out of the manual, they're able to pull up the percent of output and the voltage or microvolts reading. And then there's a little flag here that says which one of these columns it's going to use. And then it calculates the measurement uncertainty and puts it in this column. Then it sums up those uncertainties and it uses that back into the spreadsheet. So we've got examples that we give out on this that you guys can grab, use the examples and modify them for your own use. Then we have another one here that's going to look at the resolution, and that's doing the same thing. Is it's set up for the range, and the range is going to tell it the resolution. You're going to set a flag. It's going to grab the total uncertainty the resolution adds to it, and put it back into the spreadsheet. Then there's another one here for cal traceability. So each one of these points, you can put in a value off your calibration cert, and you can update these, and we'll keep them under revision control. Every time you get your standard calibrated, you can come back in and do these updates in the spreadsheet. And metrology.net will keep the old spreadsheet and the new spreadsheet up there, so you can track how the different cals have affected your total uncertainties over time. So then what happens is those values all get brought over to these inputs here, okay? And then there's another tab in here, which is the metrology.net tab, and that's what metrology.net is going to interface with. It's going to interface with just this tab, and there's a couple things that we get from the calibration while it's running. So if you take multiple readings, you'll get the repeatability pushed into here, and that will go directly into your type A column here. You'll get your resolution of your unit under test, and that'll get pushed into this column here. And by default, when we build these, we build them with the minimum amount of measurement uncertainties, so that customers come in and do that. So by default, we put zeros in here. But if you guys have another number, you can put another number in there. And then if you have something that's doing, some kind of base repeatability that you've done, or reproducibility, you can add that into these spreadsheets as well. We just don't have them in our examples. So, and then what happens is once we've done that, convert it to k=2, or whatever conversion factor you want to put in here. Once we have that done, it's going to push that up into this results column. So what happens when we want to calculate measurement uncertainty is metrology.net loads this spreadsheet, finds this tab, it fills out all the values that it has in the test points, fills all of those in, tells the spreadsheet to run its calculation, and then it reads this value back. So it's a little bit, processor intensive, but it's able to handle this very, very well. So then to upload them to metrology.net, you go over to the uncertainties, and on that tab, if you have a quality manager role, under that tab, you're going to see that there's a new calculator. And then you're going to press the new calculator, and then you're going to give it a name. You're going to give it your version number of it. Typically, you're going to want to start with 1, but if you've got some legacy thing somewhere else and you want to keep that in sync, you can set this to a different number. You can put in who's the author of it, and then you can tie it to a method in here, and then hit Sheet and Save. What that does is it creates the placeholder on the server where you can now start uploading these spreadsheets. You can come in here and tie the spreadsheet to a very specific calibrator, so that now when I'm using a 4010 calibrator, the AC voltage sine wave, this sheet will appear as an option for me to select. Then once you have all of this data filled out, the voltage that you're going to use, and then you're going to browse and find the file, and then you're going to upload the file when you hit the save button. Then what happens is it's saved, but it's not approved. So the next thing you have to do is hit the approve by. So you've got to come in with a quality role, put in your email address, or put in your login and then your password, and hit save or submit. And now it'll save that, and you'll see this revision increment. So every time we make a change to this, that revision number increments. And if you've uploaded a new file, it tags that file with the version number that it's at, so that you can track the changes inside of here. So now that it's uploaded, you've got these different sheet inputs that you can put in. So now you can come in and put in a voltage, a frequency, a repeatability, a resolution, hit recalculate, and it'll recalculate out your measurement uncertainties here. Now, I know that ISO 17025 and a lot of people want just the 2 digits of resolution. We give out more digits of resolution so that you can come back in and double check your calculations. Sometimes the value that you're wanting to check, like resolution or repeatability, you're not going to see it in these first 2 digits. You might see it down here. So if you want to be able to check that, we need to give you more resolution. But when we kick it out to the report, it only puts the 2 digits of resolution on the report. Now in metrology.net, we want to use this, so we can come in here and we can click on one of our data points. And now we can type in our value. We can drop down off the sheet of all the calculators that apply to this source voltage AC sine wave. We can drop that down, and then it'll automatically calculate our measurement uncertainty right there for us. So on the server side, it's calling the server, telling the server to load that spreadsheet and then do the calculation and return that. So you may see a little bit of a delay while it's pulling these values over. And then the other thing that you can do to get your repeatability and reproducibility is you can hit the plus button, and that'll pop up this screen where you can put in multiple readings. And then you'll see that it calculated the mean value, the repeatability, the resolution, and the count. And it'll send all of those values back into the spreadsheet. So if you want to do something like greater than 5 counts, right? Then you want to throw out two extremes and just use the 5 in the middle, right? You can add that code inside of your spreadsheet and make that happen. So now what I'll do is jump over to, so then inside of here, underneath the Uncertainties tab, so now we'll click over on the Uncertainties tab, and now you can see that I've got a bunch of uncertainties here, and then you can see that there's different revision numbers of it. I don't know, I do have my 4010 loaded here. So with the search button, you can do, crank it down. So we can grab the 4010 one that we have, and then we can come in here and play with it. So if I did 9.5 volts, and I had a repeatability of 1E minus 6, and I had a resolution of 1E minus 6, I can recalculate the uncertainties, and it brought that back that quick. If I want to download the file and look at it, I can click the export button, and you'll see that'll download the file here so I can look at it locally. Go ahead and pull that up. And then you can see that if I come in here and enable editing, get it back on the screen, enable content. So now you can see that here, if I do my 9.5 and I do my 1E minus 6 and my 1E minus 6, that I get the same value as what it returned up here. So 1.14 E minus 4 is the same as 114 E minus 6. And this is just, differences in how the values get formatted on each of the devices. We formatted it here with 2 digits. So, or actually, I don't know why that's not coming up in engineering notation. So I'll probably hit David with a upgrade to make that come up in engineering notation. So for the display. And then we can go in here and look at the parts of the summary. So we can see that our standard resolution got copied into here. Our UUT resolution got copied into here. And our repeatability got copied up into here. And then if we start looking through this, we can see the specifications. This is the range that it chose to do the 9.9 volts. The resolution, again, pick the right one. The Cal certificate. And I think when they made this, they just did a 4-to-1 on these. I'd have to go back in and check in temperature corrections, if there's any kind of temperature corrections. And you can come in and add more and more and more things inside of this spreadsheet. So, working with the guys at 1A Cal, they wanted to feed it the type of cable that was being used so that they could calculate different measurement uncertainties based on different cable types. So this here is pretty much, the world is your oyster. If you want to add some other value here, you can add it and make it required or optional, and then just keep adding more and more of these. So if there's 10, there's 30 of these things, it all gets passed in. Go back here and we'll look at another one that'll be AC voltage. Everybody out there has a 5520, so here's a 5520 AC voltage. So inside of here, you can see that it's got voltage and frequency. So you can add as many of the things that you need to add in here. And we've got examples for, let me pull this over. So we've got examples that are free to use, right? You just have to tell me you need them. I've got them all zipped up, but I got the Aditel lunchbox. We did measurement uncertainties for those. 5520, 5720, 3458, 3458, option 02, Mia Test 9000. I just did this because this calibrator has been out for a very, very short time. We've got the Mia Test 9010, the 9010 Plus, and the Transmil 4010. These are all uncertainty packages that are ready. Jumping back in here, you can see that that I've got both 9010 and 9010 Plus uncertainties up here for DC voltage. So now when I go over to my work order and I'm going to run a 34401, go in here and delete all my data points. So now you can see that if I kick it into manual calibration mode and I put it to manual entry, and why didn't it load my uncertainties? Okay, so now I got my uncertainty. So you got to be in manual calibration mode when it loads. So so now if I kick it over to my 9010 and I do manual entry, I can come in here and type in the values. And then you'll see it'll do the calculation and go to the next data point. So that was the calculation that was pulled out of my spreadsheet with that 9010 calculator. And here in a second, you'll see it'll also check against the 17025 server as well. And I can just go down there and continually enter these values. And it will do the calculation if it saw me hit the enter button and go to the next data point. So that's how they work there. And if you needed to switch a calibrator, you could switch the calibrator here and jump to the 5720. And now we should see a much better measurement uncertainty here, but we got a gray check mark here, which means that it saw a measurement uncertainty that was less than our scope of accreditation, so it did a change to that. So, and made that modification. So what I will do here is kick it out of manual mode, delete this, and now when we go to run it automated on my 9010, we can see that with my 9010 calibrator, I've got two different measurement uncertainties that I can choose. Okay, and the reason you see this up here twice is because that's the one that's currently loaded, so it just adds it to the top just in case there was a problem querying the database, getting the drop downs. So I can put it to my 9010 Plus, and now what's going to happen is metrology.net, when it runs, it's going to calculate the measurement uncertainties with the 9010 driver using the 9010 measurement uncertainties. But when it pushes it up to metrology.net, metrology.net is going to say, oh, I've got an alternate uncertainty calculator. Let me run those values through that uncertainty calculator. So now I'm going to hit run, and that tells the tells the station agent to go download those data points. So you can see it's queued. Here in a minute, it will change to running automated. And then what we're going to do is we're going to change our number of readings to 5. Right? And then this use short up here, this comes out of the process. But the process with the use short is saying that when I do 0 ohms, do I want to tell the user to put a short there, or do I want the calibrator to source 0 volts? So if we were calibrating a handheld voltmeter, right, and we need 0 volts DC, the calibrator can produce that. If we're going to do a high-end, long scale voltmeter, now we've got to tell the user to put a short there. And we'll hit continue, and this will take a little bit of time to get this first data point up here, because we're getting 5 measurements off the unit under test. So it reset everything. It gives me my connection message. So there, it's done that measurement. We still got a low measurement uncertainty, but when we pull up our parameters, inside of our parameters, we now have the measurement count. We've got the resolution, the repeatability, the STDVP, and the STVDS. So we have all of that data that we can pass into our uncertainty calculator. So the next part of this is going to be the running the automation. We did some of that already, but I did want to get into this slide. So what's the biggest reason technicians dislike automation? So I don't know if you guys want to put some things in your chat, but so I've had some customers come in and say they don't like it because they can't see they can't see what's going on in the code. So sometimes automation is a black box and the technician doesn't trust what's going on. And that's one of the things we wanted to do with metrology.net is expose everything. And then we go back into the user community and we make changes based on what the community says. These are the things we want to see get changed inside of the code. So, but I hit upon the key things with test packages. You can do the search, find your test package. You can come in and create a new asset. We didn't do this, but this is how you would run the automation. Is you're going to find the test package in the approved that you want to run. You're going to click this button over here that says we're going to run it, and then once that comes up, this is going to create the work order. So you can either select an asset or create a new asset. Anytime we put in a new asset, we want to know, we've brought over the manufacturer and model. We want to know the asset number, the serial number, any notes, and you'll get a drop down of the options that we're going to create the test package around. And then we use we don't have a work order management system. So we use the date when we're creating the work order. So inside of here, we're saying the year, the month, the day, and the sequence. And then we can do as found as left data collection mode. And we can assign it to a workstation and assign it to a person. From there, we can see the station that it's connected to, and we can see the different ways that we want to run our data points. And then underneath when we hit the little run button, as you saw, I get a list of my techniques, and I can select my technique, and then I can select the uncertainty calculator that I want to use. And then it will start running the procedure, starting off with the configuration screen. I get this little halt button up here where it says this is the status and this is halt. The button, it's a halt button. It doesn't mean it's that the program has stopped. It's a button that's up there that lets you halt it. I've had some people come in and say that it's not running because the halt button is up. And I'm like, no, it's a status. So inside of here is where you see the current status, and then the button comes up as well as giving you your connection messages. And then it will run through all the calibration. And you can see that when we put this training together, we didn't have the check with the 17025. So that wasn't available yet. So then when we're done, we want to see the calibration data. We've got a calibration report here, and we can pull up all of our calibration data. So when you're getting ready to run a test package, anything that's approved in here, you can run. I'll go in and look at a 34401 because we do a lot of those. So here I've got a 34401 in here, and now I can put in my work order. I can do as found. I've got all of the different workstations I can save it to. It's typically 03. I can assign it to me, and I can also come in here and check the options. So I have no options set for that. And then I hit the create work order button, and you're going to see it chug a little bit. But what it's doing when it's creating the work order is it's going through and looking at all of the test points in the package of a 34401, breaking it down to what we're going to test on a 34401 with no options. So you can see it work through all of that, and I can wait for it to automatically go, or I can click to go to the work order button. And now I can run everything with that. What I'm going to do is just grab this as closed, and then I'll go back into one of these other work orders. I believe we have one that is complete, which is this one. So this one has been completed. This guy was ran on a 34 or with a 5520. So there's one data point that you can only do with a 5720 and a boost amplifier, which is this 750 volts 50K. But you can see that the cal report when we run it, we'll grab a non-accredited report. You can see that the cal report when we run it is going to give us all the data that was collected on that item. So you can see here it's a failure, and then you can see all the data that was collected. So that one data point that we weren't able to do because we didn't test it, we don't report it back to the customer. We can build cal reports that'll say something's not tested. We just haven't built that yet for any of the customers out there. And then the users can download this and attach it, or there's a whole bunch of things that they can do with the REST API, pulling back all the calibration data if they want the raw results. So that was the second of two training videos, or the second of a series of training videos. So we covered the measurement uncertainties and then how to run a procedure and get your data out of it. We've got some more advanced features coming up, so stay tuned.